And now we'll turn to English and we'll look into mobility and autonomous vehicle driving. And this is a challenge that we have been discussing with Siemens. And I would say Siemens is maybe one of the world leader in this field because they've analyzed the megatrends, what is happening, and they've analyzed also what's happening within the cities with autonomous vehicles. So we ask for an update on where Siemens is and how you think the world will move on from here. So Kunal, Chandra, this is your speciality, and we're happy to have you on the podium. So please, the floor is yours.
A very good afternoon, everyone, and thank you for having me in this session. Wonderful. And when I was preparing for this presentation, I was thinking how to discuss the vast issues of smart cities and smart mobility in 20 minutes. Then I thought I'll keep it simple and I'll just tell you the right answer. The right answer, in my opinion, is ACES. Of course, I'm joking, but I believe that the ACES framework, which I will share with you in the next 10, 15 minutes or so, provides a useful thinking paradigm in which to understand the challenges that are faced by mobility, but by the cities, in fact, and then the solution space that could provide a relief from these challenges. First, greetings from my lawyers. So please don't buy or sell Siemens shares based on what you hear in the next minutes. And a few words about the company. I think it's quite important to understand where the company is coming from and how we see the trends going forward. We are one of the oldest companies on the planet, and we in fact operate in as many countries as the FIFA Football Association. In this 173-year history of the company, what we have realized is that there has been a constant evolution from what we call Industry 1.0, which was driven by a one-dimensional steam-powered engine, all the way to what we now see as, and we call digitalization. So for us, digitalization is a next major transition originating as the natural consequence of the previous three, namely steam power, electrification, electronics, and IT. Very quickly in numbers, so large corporation, about 300,000 employees. And this is Siemens in its most recent avatar. Last year, we separated Siemens Energy and we put it in a separate entity and floated that entity on the German stock exchange. Siemens Energy has another 80,000 people and about 30 billion euros in revenue. Now, what am I doing talking about mobility? Well, if you are a user of a car or a driver or an owner, it's very likely that you have been our customer, even if you would not readily associate us with automotive industry. So therefore, moving on and talking about the role of mobility and digitalization in the smart cities of the future, let me start with this picture. Some of you might have seen this. This is Fifth Avenue in New York, where we have the famous Apple store in 1900. What you see on the screen is horse carriages. And amongst these horse carriages, there is one car. The question is, where is the car? I'll tell you, it's here. And you can't see it, so you just have to trust me. That's one car amongst hundreds of horse carriages. 13 years later, this is the same New York City, Fifth Avenue. And the question is, where is the horse carriage? And I'll give you the answer again. The horse carriage is here. How long before the cars will disappear like the horse carriages that disappeared in 13 years of time? I think the case for change is quite clear. Urbanization is putting a very heavy demand on cities. As you can see here, many more people will be moving to cities over the next 2 or 3 decades. We will be having many more megacities. So today we have about 33 megacities defined as 10 million in population. That's 2 times the size of Norway. And within a very short period of time, we can see 10 more megacities. And with every decade, you can keep adding 10 or 15 megacities on the planet. Now, such urbanization is not going to be without its set of problems. As you see, this will put tremendous pressure on the infrastructure, on the city infrastructure. And now, emphasizing what this would mean for mobility, this would mean that the number of passenger miles traveled in cities would grow from 44 trillion today or a few years ago to 120 trillion by 2050. So that's 3 times increase in the total number of passenger miles traveled. And this, as we can all imagine, in the base case, would be practically unsustainable. So the problem is significant. And just one more statistic. Today, the cities are having less than 2% of the total land area, and they are supporting about 58% of the global population. And going forward, as you see here, this number is likely to increase, and therefore the status quo is not enough to extrapolate into the future. These challenges, of course, present opportunities, and the biggest opportunity comes from two of the topics that are addressed today. One is digitalization, and the other is, of course, the role of energy transition. And these opportunities are quite tremendous. For example, if we look at the role of public transport or shared mobility, there's an increase the share of public transport from about 20% today to more than 50% in the future. There's also a $1 trillion opportunity in the market of what we call smart cities. This opportunity, of course, shows up in terms of all the kind of sensing, computer vision, data lakes, platforms, intermodal solutions, etc. And therefore, while there are challenges, there are opportunities. And I believe these opportunities are contained in what we call ACEs. Some people call it CASE. I just think ACEs is a bit more catchy. ACEs highlights the 4 transitions that must happen in the space of mobility almost all at the same time. So the cars must go from today being driven by humans to autonomous. They must go today from being standalone to connected. They must go today from being run on diesel or petrol to electric. And they must go today from being owned to shared. I would like to highlight that these 4 trends are not standalone. And in fact, they are mutually reinforcing. For example, autonomous vehicles can be more readily shared, and electric vehicles can be more readily made autonomous. So all of these 4 trends, when they play out together, they can create a tremendous impact on the way we experience mobility, and therefore also on the way we experience our cities. I'm going to walk you through just one vignette for each of these trends. And then I'd like to also leave time for questions. That's the most interesting part. Starting with autonomous. Just to give you one particular use case, again, looking into the public transport. If you look at some of the major European cities today, we are really facing a challenge with the first and last mile solution. What does this mean? For example, if you're traveling between Berlin and Munich, you can easily cover the large part of the distance with a train, with a high-speed train, 3-4 hours at a cost that's reasonably affordable. And some numbers here, so for example, about 1 to 2 euros per kilometer or even less. But once you reach the station in Munich, you have a few options to get home. Yes, you still have the metro system and the trams, but they are either not responsive enough or they do not have the kind of flexibility in terms of getting close enough to your home. And therefore, you choose to go in a taxi. And there you suddenly see that the cost traveled per mile goes up quite significantly. You also see that the carbon intensity of such a drive is quite significant. And the congestion that it causes on the streets, etc., would also be another problem because of a lack of first and last mile public transport. So this is an opportunity where autonomous technology, for example, can address the issue by using smaller shuttles, which are demand responsive, which can get you as close as possible to your home. There is an opportunity for us to reduce the overall demand on the mobility infrastructure. This already today we see as a big market opportunity. So we believe that the autonomous driving by itself could be a $100 billion market. But out of that, the autonomous shuttles that I just showed you in public transport could already be a $20 to $25 billion market and could significantly reduce the carbon footprint, but also the congestion issues that we see in many of the European cities. So that was on autonomous. For connected, I'd like to play a video. I hope it works.
The world is moving faster than ever before. With the continuous rise of traffic and the increasing demand for efficient public transportation, cities worldwide are facing a multitude of challenges. Challenges that can be solved. How? Follow us. The backbone is the Mobility Operating System, the MOS. It connects and manages the infrastructure, fleets, and all participants in the mobility network. Traffic lights communicate with each other and the control center, not only to react to appearing situations and demands, but also to anticipate them, optimizing speed and making traffic more fluent. Cars, buses, bikes, and other means of transport are connected with the overarching system. Additional information from our intelligent infrastructure enhances the environmental perception, enabling predictive driving, avoiding hazards before they occur, and thereby helping to achieve homologation of complex AV systems. Mobility solutions like self-driving vehicles, e-bikes, and more are part of public transport, providing the most efficient journey for the first and last mile for every single traveler, inside and outside of the cities. We develop systems that talk to each other. Artificial intelligence makes the MOS even more effective by helping to anticipate situations and proactively deriving decisions. We provide mobility data in scalable packages, a business model for more efficiency and agility to connect your city's ecosystem even better. Follow us on the digital path of mobility.
I think the idea is that the amount of data that we are generating today, and just to put this in perspective, an autonomous vehicle navigating through a high urban environment generates about 35 terabytes of data per month. And the kind of data learning tools that you can apply to this in order to not only make the driving pattern of that particular vehicle, but also the entire traffic flow into that city effective is presenting one of the biggest opportunities that we have seen. And in Siemens, I think through this video, what we are trying to share with you is just the kind of the bits and pieces are all there. And together with a combination of sensors, which is not an easy problem to solve. People think that the sensors are all there and we can really start to install them, but they have to be ruggedized, they have to be reliable, etc. But once we have gotten beyond that, the amount of opportunity that we see in this space is quite remarkable. And then, of course, the sensors provide us a cyber physical system. And then on the back of that, we augment the entire system with what we call data lakes to provide us big data. And then low communication architecture through, for example, 5G in the future, which is what we call fast data. And when you put big data and fast data together, I think in the space of mobility, you get quite a revolution. Then let me move quickly to the role of electric. I think perhaps this group needs really no more new information to understand how important electrification of transport is. As we see today, transport is accounting for about 20% of the global CO2 emission into the environment. And this is one of the hardest CO2 emissions to control, simply because they happen in small quantities in a very distributed manner across a very big geographical space. There are opportunities to get rid of this transportation CO2 footprint, particularly, of course, in electrification. But we also believe in Siemens, and that would be another part of Siemens' portfolio. But nonetheless, we believe that the role of electric fuels, so fuels where you use hydrogen as an intermediate and then produce, for example, synthetic fuels, synthetic diesel, etc., would be quite important. If you look at the economics today, the electric fuel or the synthetic fuels are not as competitive with, for example, another option like biomethanols. But if you look at their CO2 footprint, the CO2 footprint of electric fuels is significantly lower. And therefore, sooner or later, once we want to decarbonize the transport deeply, we will have to move into the space of synthetic fuels. This would mean that the total amount of electricity required, both for direct propulsion of vehicles, but also for indirect production of synthetic fuels, would put a huge demand on the electric grids globally. And with one estimate, we believe that actually in the next 30 years, by 2050, in order to achieve the Paris climate goals, the total electrification should grow by a factor of 4. So that's another huge opportunity business opportunity for electrification, but in fact, digitalization will have to drive this kind of manifold increase in electrification infrastructure, but also ultimately using this infrastructure much more efficiently. So, as I said, these trends are quite reinforcing. And with the advent of digitalization, we believe that each of these trends will accelerate. Lastly, why should it all be shared? Why could we all not just own our own autonomous cars standing in our garages? Well, just one statistic. Here is some data from a study that was done by Uber in San Francisco, which is one of the biggest markets for Uber. If we continue to rely on things like taxis or passenger cars, no matter how responsive they become, Uber is far more responsive than a normal taxi, for example. You still see that the utilization rates achieved on these taxis is not very high. And therefore, even in a place like San Francisco, you achieve only about 60% utilization rate, which means there's still about 40% of the time these vehicles are going through the city and really not providing any meaningful passenger service. If you now go with autonomous shuttle or autonomous taxis, you can imagine that these taxis will be much cheaper and therefore very likely that there will be too many of these taxis with much lower utilization rate. So we therefore also believe that autonomous transport should not be in so much in the private sector, but much more in a kind of a public shared space. This is kind of the framework that we use to drive our strategy within Siemens. And we believe that with ACES, we can go from this, which is a very familiar sight in many urban cities today, to something like this. And that would be our vision. And I hope I hear back from some of you, whether you share this or there are alternative hypotheses. Thank you for your attention.
Thank you, Kunal. Extremely interesting. I have one question for you. When will it be possible for me to actually use an autonomous vehicle? It can be a taxi. And where will this take place?
Well, I think there are two questions. I think one question is, when is technology ready? And I think the technology in many parts of the world is already ready today for simpler, what we call operational design domain. So today, if you fly to Arizona or go to Phoenix, and there you can ride a Waymo taxi, well, that's kind of more like going to a theme park and enjoying a ride. It's really not integrated into your daily experience. And I think the question is, when would this become a part of your daily experience? This, we believe, would be meaningful only when you can do these rides in highly populated urban areas. So for example, if you're in the heart of London, trying to get from Paddington to Westminster, this we believe would probably be possible around 2030 in countries like Singapore, as you said. But there is a precondition that these vehicles will have to be supported by high quality V2X. And I think somebody asked me a question, is V2X mandatory? We believe that in high urban density areas, V2X is mandatory, simply because we have done some calculations. If you look at amount of computing load that you put on a autonomous car, if it's in a high traffic area, that computing load is a factor or a couple of factors higher than when they are simply driving on a highway and just changing lanes, which is what you see mostly today.
Well, thank you so much.